Thanks.
All right, cool. We are here. Welcome, everybody. Let me shut my door so I don't drive my wife crazy. Chris Neidl here for our latest weekly Monday stream for our Epiphyte open source direct air capture project. I'm joined by David Wilson, Seth Sternberg, two founding members of the team, and we're excited to also have Thomas Brigham, who's here in Austin, as I am, from the UT Net Club, also joining. So, hey guys, how you doing?
Good. How are you?
I'm well. Cool. So we have some updates. David, really eager to kind of get you up to speed and answer any questions that you have from what we've covered over the last little while. Made some good progress. You want me to just start with a couple of the housekeeping things about orders and stuff, and then we can kind of hear from you on any questions you have?
Okay, very good. Because I don't have any new information since a couple months ago.
We'll bring the new information. So Sandelia cannot be here today, but will be with us next week. And I've been talking to him frequently. David Sandelia is he's an engineering student at UPenn, who is going to implement the swap outs that we have for the different components that we want to change, right? So we've already ordered the new sorbent, the Luitit. That's going directly to the chem lab. Talked to Peter Saros about it already. 1 second. All right. And then we got, we also have, we ordered the sensors, Seth, these two guys. Let me show you the picture here. So we got one of the evaluation kit, right? And we got two of the bridges.
Yep.
Okay.
And I know there was a lot of discussion, in the various back channels, but just so everyone is up to speed on this, the reason we selected this sensor is that this is the only one that's certified up to 100% CO2 concentration. Most of them are certified, to pretty small amounts, which would be fine for adsorption, but would not work at all on the desorption phase. So that's why we went with these.
Okay, awesome. And let me get us back to our faces here. And then we have, so that's great. So those have been ordered. That should arrive at Sandelia's house today or tomorrow. And I think the sorbent has probably already arrived at UPenn, but I'll have to check in if they haven't received. The other thing that we have done, so it's good news that Sandelia will be able to be at the lab next week, David. So it's also a thing where he can kind of point his camera. We can kind of just revisit the physical object, look at the gaps in the sorbent chamber and all those sorts of things. The other thing we started to talk about last week was some of the replacement potentially of the damper because of we thought that was too flimsy, right, David?
Yes, and leaky.
Okay, so this was the one that we used last time, which is in our fully updated bill of materials on our GitHub, and you can see how it sort of fit in there. And that was just 3M tape that we went around with it, right, to seal it, David?
Yeah, Chuck did that.
Okay.
But you can see it's always going to be leaky just because of the way it's designed.
Okay. I found this guy here just looking around online based on the description. It's something called a bubble tight low leakage damper. Again, I added the spec sheet in the catalog in the Discord, but it's 10 inches, I believe. And so I'm not sure if we're looking for an upgrade of something like this, but just figured I would get the conversation going by looking at some options. I don't know if
What's that thing cost?
This is, I think, I was looking at eBay for it too. They're like $50 each.
Oh.
Yeah. So I don't know. Does any of this here look like it answers any of our questions? Or again, I don't know. You'd have to take a look at the catalog in detail.
Yeah, unfortunately, that's not the kind of thing I know much about. And Chuck would have been the person to ask. You might be able to get email it to him and see if he comes back with a response.
Okay. So let's go down that. I'll copy you on there just in case to close the loop, David, if that's okay, or I can just
Sure.
copy and paste it. Okay, great. All right. So quickly back to the sensors, real quick, Seth. Is there for the installation? I can't remember what the software component was, and what has to get sort of changed there. It's not just sticking them in there. Obviously, they have to get turned on and all that. What's the
That's a good question. It's possible that the driver API is the same, and that there really is very little to change.
There are probably some details that are different,
Was
but
that?
it shouldn't. There are probably some details that are different, but it shouldn't be too hard just to, take the software I already wrote, if you want to use that, and just add a replacement function for this one without taking anything out.
Do we have that? I can't remember. Is the code in the you shared the code with Ling? Is that in the GitHub?
It's in the GitHub, yes.
Okay, great. Is that a relatively easy thing to do as somebody who knows their way around software to sort of plug in the new code for that?
I think so, if they're used to programming Arduinos and stuff.
Okay. Seth, do you need help on that, or would that be the kind of thing you might be able to look at the code and see what has to get snipped and added, or should we pull in some other folks? I know Aiden at UT is a software guy. Thomas, he was interested in software aspects of this, but
Yeah, no, that's pretty straightforward, actually.
okay. All right, cool. And so what we're hoping, David, is that Sandelia is sort of, I don't know if you saw that email you did from Peter, clearly level of enthusiasm and interest there. He's got access to the lab. So what I think would be good next week with the new components in hand, just to first do kind of a virtual walk around of the device. I'm not sure if you're able to make next week. Totally fine if you can't, but it's a good opportunity to.
I should be,
Oh, look,
and I should be able to. Oh, there he is.
What's up, buddy? How are you? I'm glad you could make it.
Yeah. So the link was not working, so I was having a hard time to get in.
Okay, cool. Yeah, I didn't think you were able to make today anyway. So very good to see you. So I was telling these guys that I sent you the tracking number. I think that the updates will come to me for the sensors, but that looked like it was a pretty quick shipment. So you might even get that today or tomorrow.
Yeah.
And then I'll check in to see if UPenn has already received the sorbent.
I guess they did receive the solvent, but I'll have to go check and see if the package belongs to us.
Okay, great. Sandelia, have you met David before?
No, I guess I have reached out to him a couple of times to ask about a couple of sensors, but yeah, this is the first time I'm meeting him in person. Hello.
Meet men in person. By the way, I should have some time in the next couple of weeks to stop by the lab and show you some stuff.
Yeah.
That would be helpful. My pen pass is expired, but maybe you can just open the door for me.
Yeah.
And, I wanted to ask you, Chris said you're an outgoing Penn student?
Yeah. So I'll be graduating this May, but I'll be in Philly till 28th of May.
Okay, so you have a deadline.
Yeah.
Yeah. There's one other engineer, and we're hoping too, David, that with Peter now having the documents, and there is one other engineering student who I have to introduce you to, Sandelia, who reached out to me at UPenn, who's actually interested. So if we can get as much done as possible before Sandelia heads out of town, that would be great. But hopefully there could be a bit of a passing of a torch there as well.
Hand it over, pass the baton.
Yep, exactly.
Yeah, I'm mostly planning to devote this week and next week to Epiphyte, so that things get moving, and also maybe it becomes easier for the next engineer to come and just take over things. Yeah.
Yep, great. So I did want to talk a little bit about looking at the filter box as well, because we talked pretty extensively last week, David, about Yoken, Ling, and Tim could not join today. So. But they're starting to look at options for a small vacuum integration as well.
Yeah.
So I was going to kind of look at the screenshots I have of the spec sheets for those. just so we could potentially make a call on that. That's kind of a nice to have. If at a minimum, Sandelia, we can get the sorbent in and the sensors swapped out, and then maybe some cheap jerry-rigged kind of sealing a little bit. We were talking about, I think, silicone sheets and clamps to just try to, for the purposes of testing the sensors and the sorbent, closing up leaks a little bit better.
Okay.
That a little bit last week. And if we have time, we can see if we can add the vacuum. But if not, then we'll have whoever your successor is can implement that part.
Yeah, sure.
Cool. David, what kind of questions you have or thoughts or anything like that, just for catch up? And otherwise, we can kind of talk a little bit about concrete steps for what to do first with Sandelia's help.
No, I think I'll just listen to what comes next and ask questions when I think of them.
Okay. Do you guys remember? I wish Tim and Ben were on right now, but the sorbent is out of the box, I believe. I don't think it needs any special treatment. You know, we're not going to make any changes right now, David. We know we have to make changes where we don't have the box completely stuffed with sorbent that might, you know, be a problem for airflow and energy and stuff. So we're hoping to kind of more or less take out the zeolite, give it a little bit of a wipe down, and then put the new stuff in there. Anything you'd recommend against that, or is there another step that we've discovered that's relevant?
No, but you might, Sandelia, you might want to make sure you talk to Mary Lynn before you do anything, because I think she has a lot of concerns about safety and to figure out what to do with the old sorbent, you know, how to go about doing it without doing anything dangerous, and check the safety, you know, the MSD or MSDS, whatever it's called now, for the new sorbent. I don't know if it's how poisonous it is.
Okay, good point. All right, let's take some time on that for sure. We'll look at the I'm sure that's listed on the product, but to be extra safe, if we want to reach out to the manufacturer, you know, whatever is best practice there that doesn't create any risk, would be good. With the machine too, David, is there anything that we would say is broken right now, or a very quick fix that we would sort of add to it to make it function better beyond just the idea of putting new sorbent in and changing sensors? Or
there are a couple of detailed things that I can talk to Sandelia about. Actually, once you open it up, you might see if anything is broken as far as the thermistors. See if whether any of them have shifted their location. Okay. Also, one of the, he probably won't be using these, but one of the flow meters isn't working, and I'm pretty sure I know why. There's a loose wire somewhere.
Let's take a look at some pictures here. Is this the thermistor or whatever you just said, David? Is that visible here?
No, that's before they were put in. That's the heating wire in the middle there.
Let me see.
Although the thermistors are in there somewhere. They're just little pairs of wire with a lumpy thing at the end.
Okay.
And I think they're taped on to the heating wire at various places with Kapton tape.
All right. Well, once we open it up, we can look at it and give you some guidance, Sandelia. What was the second thing you said, David?
There are flow meters in there that one of them doesn't work.
Okay.
And it's probably just a loose wire somewhere.
Okay. Cool. And one thing I never saw is stupid question, how do you turn things on and how do you turn it on and turn it off, and then look at the results and all of that? Once we get these things swapped out, we want to start testing it. I don't know if you want to summarize that now or if it's worth just doing it next week.
Probably do it next week. There are several things to turn on. Like there's a box that has the 24-volt power supplies for the heating circuit, and it's connected to a power cord that has a switch on it. You have to switch that on, and there are a couple other things that have to be switched on, and you have to have, of course, all the software loaded onto your computer if you haven't done that yet. And then just, there are a couple of switches also. There's a switch for running the system, which controls the temperature of the wires and reads the data. But before that, there's another switch where you can set up the temperature. There are a few steps, and it might even be easier for me to come down and show you.
Okay. Great. Hey, Jochen, how you doing?
I'm fine. Sorry, I was late, but the one link didn't work, and somehow Discord is always the last resort I look at.
I'm glad you looked. Yeah, I put the view link instead of the join link. Sorry about that. So great to have you here. Really good. We were just kind of covering now that the parts are ordered. Jochen and David is back, just getting Sandelia completely up to speed so that we can make those two changes. And then I just was asking him, well, how do we turn it on and monitor it? And David was just summarizing that because we're going to want to start testing. What are the times again? Like if you ran it a few times per day, like what's the amount of time it takes to do the full absorption and then the desorption?
Well, with the old sorbent, it would take on the order of an hour before I consider that it had finished adsorbing, and then maybe another hour to release it.
Okay.
But that's all judging by what I saw on the CO2 sensors, which were flaky at best.
All right, so we'll have some answers to that.
Yeah, I asked that question before. Maybe ask it again. Did you guys look at what happens at the direct surface of the sorbent and into the whole thickness of the material in terms of saturation?
No, we didn't really have a way to do that.
Okay,
It's all kind of a black box.
fair enough.
Yeah. Is there a way to do that though? Do we ever thought of something like that there is a way to measure the saturation of the sorbent, or it just stops absorbing? Like, you just get a steady state basically on the readings for the CO2 in the chamber. Is that how we did it?
Yeah. And the readings were never conclusive. You could see at times if you know what the concentration is on the input, then you should theoretically be able to read the output and tell from that how much it's absorbing, and when it is saturated, then the output level should equal the input. But due to I think the turbulence on the output side of the system, we never got usable readings on the output side.
Okay. Do you think it makes sense, David, to do, before taking out the sorbent, change the sensors and run it with the new sensors a few times just to get like a correct reading maybe of how the old sorbent did, and then do the new sorbent so we can see a sort of a delta?
I think that's probably not worth the time it would take, because all these things take more time than you think.
Okay. Okay. Sounds good. Any questions, Sandelia, so far up to this point, or?
No, I was just curious, what sensors are we using currently for the previous round?
For the previous one, let me grab. Unless Seth or David, if you know off the top of your head, otherwise I can look at the bomb right now.
I'm sorry, I didn't hear the question.
Yeah, I was asking which sensors were we using for the previous rounds?
Which sensor? The SCD, I think 41.
Okay.
Looking at it in the.
I don't have anything open in front of me now.
I have the bomb open in front of me. I'm just trying to find it on there. Sorbent chamber sensor. Okay. I see the Adafruit cable feather extender sensor. Here we go. Yeah, this is the one here. I'll drop the link for you. Quickly.
Okay.
Okay, so if you look at this, this is the one here. That was it, right, David?
Right. Okay. Yes. SCD30. The 41 was something I used in a different project, and that is an eval board that's you get from Adafruit, whereas actually there's a small board that Sensorion sells, and then Adafruit mounted it on its own board for rigidity and to provide some power supply control. But I had to do a workaround because I think the way they did it gives insufficient voltage to the sensor supply when it's reading it.
Okay.
Okay. And these are the new ones, Sandelia, which are coming to your house.
Okay.
Right. Another thing we talked about last week too, David, and Jochen can summarize it, is we had an idea of, could you have, oh no, that was for the vacuum. Sorry, I'm getting ahead of myself with applying the vacuum. Okay. So that seems like that's clear.
Chris, the one other thing we talked about in the sensors and using the sensors to test the new sorbent is smoothing out the data. So, one of the problems we had in the data that made it hard to read is that it's just fluctuating all the time. Some of that is the turbulence. Some of that is because the response time of the sensors was not designed for our use case. So what we talked about was, instead of plotting, and this isn't anything on the sensor side, but when we plot the data, instead of plotting each raw data point as it comes out, you take that data and you do what you actually plot at any given point in time is the average of, say, the previous 3 seconds worth of data. So
Like a moving window.
Yeah, so that sliding window gives you a much smoother curve. And
yeah, you could even do that in Excel.
Yeah, you could even do it in Excel. Yeah, it's just when you plot it, you either do it in that way in Excel, you do it in the software, wherever you do it. But it should make it a lot easier to see what's going on.
How does that work on an Excel, David? Does it just you have the sensor, the software sort of output to an Excel document, or?
I just have it output to a terminal window, and then I cut and paste it.
Okay.
Oh, by the way, for anybody that programs, the Arduino IDE has a terrible interface as far as the serial window, and you can't cut and paste the whole thing from it. So I use a different terminal for capturing the data. I think it's what is it called? It's not TerraTerm, but it's another one of those. Putty. I use a terminal called Putty, Putty, for when I'm actually running the program and reading the data, because then you can just capture thousands of lines of output and just cut and paste the whole thing.
Okay.
David, would it be useful to just pipe that to a file instead, or in addition?
Sure. Yeah, I never got that to work.
Oh, okay.
Do you know how to do stuff like that, Seth?
I used to, but if David couldn't get it working, then I could take a swing.
All right. Well, we can take a look at once we start getting that, and we can try to figure that out at the appropriate time.
That's a minor detail, but
Yeah.
it'll make life a little easier.
Okay, gotcha. Sandelia, any other questions on your side?
Yeah. So with the data, are we using any sort of database to store all the previous experiments, or are we just getting into raw Excel files and sort of doing our own analysis?
Most of the data are sitting here on my laptop.
Okay.
But can we do that though? I wonder, is there a way of having that automatically pushed to a folder of some sort, or even to a server? Because Seth, this starts to become relevant to you. Even with this one unit, I want to have a website that has the data showing, and then as we add more of these this summer, we'll have a platform that people can look at different ones. That's probably relatively easy to do you think, or?
If we can get the data out to a file, then we can get those files out onto a server.
Okay. Can that be automated though, where it would automatically push to like a Google file or to a server? I guess would probably be better, right?
Yeah, as long as the Arduino is online. Yeah.
Okay. Woo, that's exciting. So we got 24 people tuning in, by the way. I just want to welcome folks who are watching. Feel free to plug in comments based on what you hear in the chat. We had a couple of good ideas that came in 2 weeks ago from someone watching on Twitter or X. So let's keep that going. Let me also drop for folks the brochure in the comments. This just has the summary of what we're doing this spring with the project, a little bit of background, as well as the link to the GitHub and the forum and the calendar for these meetups and how to watch them on YouTube. All right, cool. Anything else to cover before we talk about a little bit on the vacuum front? Jochen, I have some screen caps of the spec sheets for the stuff that we used already, and I shared those with you, but we had some good, I don't know if you want to summarize what we were looking at last week for David's benefit and Seth's benefit who didn't join.
Yeah, well, my thoughts have developed a bit further, hence the suggestions on Discord. But basically, as Tim and I were agreeing, the vacuum we need to have is not that sophisticated. So in terms of seals and everything, it's not overly complicated. It's just the material that Tim has suggested and that I know from my past is very soft. And normally when you use it in vacuum installations, it has kind of metal profiles around it, so it can't move anywhere. And for that, you need a certain surface. And that's why I asked for this video call to maybe take apart something and look at them in detail so that we can get our head around whether there is sufficient surface or whether we need to come up with another idea.
I found this thing here. Let me just show a couple pictures. So this is just the product out of the box that we had and obviously how it was applied. And then within that catalog, it's not showing the whole thing. I guess you have to go full screen on that. But the one, where is it here? Crap. Well, that document, if you look at, there's the one for the specific product, which I think was SFB 10. It gives, this is the information that we have along the top there. I don't see anything about thickness of the. That's what you're looking for, right?
Yeah, and also at the moment, I think I'm more interested in figuring out how we can seal it, and then maybe we just, if we find a way of sealing it, then we just give it a short try and then see how that behaves and how many holes we have and whether we get the pressure down at all.
What were you guys talking about with the sealing? You said silicone sheets and clamps. If we look at the actual device, are we talking about just the box in the middle of the filter, just wrapping that with a adhesive silicone sheet, and then sort of wherever we see things that are really open, trying to use a vise or something to seal them? What in practice would that look like?
Yeah, that's why I guess we need to look at exactly what kind of surfaces we can use the sealing kind of material for. Normally, you would have to use it where the flat surfaces, the rectangular surfaces meet. You need to do it where the cone attaches to it, and you need to seal where this other tube sticks into the cone. Because I don't think that, I think that's just metal sheets bolted together or so, isn't it?
That's right. And it looks worse up close than it does in the picture. They're a little...
Oh dear.
And it feels very flimsy. You can press it in with your hand.
Okay.
Which part, David, can you press in with your hand?
The entire thing, all the flat metal parts.
Oh, really? It's that? Oof.
Yeah, normally they are used for, for slightly pressure above or to conduct airflow. So there is no real focus, and there's always sufficient airflow, I guess, from the vents that they are normally used with. So leaks also are not necessarily a concern, but obviously if you're trying to do the opposite and apply a vacuum, I don't even think in its current state it's worth connecting a vacuum pump to, from what David has just said, at least.
Well, if you're willing to sacrifice one, you can do an experiment with the vacuum pump and see how much you can evacuate it before it collapses. It's a little thicker than a soda can.
Yeah, I don't. From here, I cannot tell at all. That's why I would love to be there and touch it and see it. I mean, you could probably you could connect the vacuum pump and see what it does, and then the moment you start to see some changes, you switch off the vacuum pump again. That would be my idea to start with, and then maybe after that has been done, we could start thinking about the sealing, because I think at the moment there are so many holes in there that I don't think anything will happen to the shape. If anything, if there is even a vacuum to speak of in the current state, even if we connect the vacuum pump. That's why it was suggested a video call, so that maybe 3 or 4 of us can look at it and someone is in front of the thing and then take things apart or so, and then we can maybe do a little bit of a constructive brainstorm.
Yeah, hopefully next week even we might be able to do that. I think that would be the good thing. Will be just kind of like looking at it up close and sort of
that would be helpful.
Thinking about, but even the type of vacuum that you sent me a link to, Jochen, it's cheap enough for us to get one, and not yet. We'll wait and see once we've done next week and stuff, but it's definitely something we could test out. And if we see any movement of implosion or something like that, we just turn it off. But it wouldn't be a bad stress test to do anyway.
Yeah, I think so too. And when I looked at those pumps, I mean, it was just a very quick kind of search, and I was looking for something that didn't use too much power, that was the type of pump mechanism that I thought was appropriate. That wasn't too expensive, and that you could easily do a test run with, and then maybe at a later stage, if it needs to be more sophisticated, we need to have another look at the pump. But for sheer functionality, it might well be worth it. Okay. But maybe let's wait. Let's wait if we can have someone standing in front of it and put a hand to certain things that we can look at in more detail, and then we can firm up what we want to do.
Yeah, that sounds great. David, do you remember when you and Chuck looked? I know Chuck did the order on that, but when we did, I would imagine there's probably a number of similar products that have the same form that wouldn't require us to fundamentally change the design, but that are a little heavier duty.
Well, first off, it's hard to tell from the catalog, and I don't remember that we found any that were that different. They're just different in shape and size.
Okay. It's pretty simple though, the way it's shaped, right? We could probably find something, even if it's another supplier, that it's basically a similar type of function. But anyway, that'll just be a research thing we have to do, or maybe I can call the manufacturer and tell them what the use case is and see if they have any thoughts.
I think it could also be a cube, and in fact, our friends at Octavia, they built their own. Out of sheet metal, and I guess they had metal tools and bent the metal themselves into the original box, and they've come out with different shapes, but the shape they ended up with was a cube.
Yeah.
Interesting.
All right, noted. So we'll test all these things out, but it's probably likely we'll go with some other chamber that allows us to more or less maintain the same concept, but it's just a little tougher. So all right, so next week will be very exciting. Anybody else have anything they want to share? Otherwise we could and Thomas, feel free to weigh in here. Excited to have Tom joining us from the UT team, because that's one of the places where when they get back from the summer in the middle of August, we want to build one of these bad boys. I'll be able to see it myself. But yeah, feel free to weigh in, Tom, if you have any questions. Otherwise, anybody else have anything else to share? I was thinking of asking a sensor and software question of Seth, but let me know. All right. So Seth, do we want to, I'm wondering if now is the time in conjunction with these upgrades to go ahead and try to execute on just some basic web-based reader of the data, and didn't know what your initial thoughts are on that, or what I should go find, or it'd be kind of cool if we did a true hello world that people could look at the numbers actually on a screen, even if it's just one graph. I don't give a crap, you know what I mean? But whatever.
Yeah, no, I think it's absolutely the right time to start doing that. I mean, there's some work involved, but you can get to a point actually where, if we're able to write the data to the file, get the file up to the server, right? We can have the server actually doing the plotting and doing that sliding window and whatever we want to do, so that whoever's working on it, David, Sandelia, Thomas, whoever's actually physically working on it doesn't have to do that every time when the data comes in. The data will just be live on the server for every run we do.
Yeah. Be awesome.
So that's what I would consider to be the first step, is to try and get to that point.
Okay.
And you need someone who knows a little bit about the back end to get the data across and how it's going to be stored. And then, it's fairly simple web programming to do those plots.
Yep. Okay. Awesome. That'll be exciting. So to jump ahead for a second, as I am always inclined to do, Seth, I'm curious, like, if we look at what our sensors do, right? Mm-hmm. And let's say a year from now, we have 6 Epiphytes humming along in various parts of the world. Do we have enough data that's coming in from that, like environmental conditions, like external temperature and stuff like that, where you could see a future where if you have an outlier performance of a particular DAC that's like the best capture of a particular run, that you can then look at what's the data we know about what the operating conditions were from it? You know what I mean? You see where I'm getting at with this?
Yeah. So, I mean, we can get whatever the sensors are giving us. So right now we're getting, in addition to the CO2, we're getting temperature, pressure, and humidity. So right now we've got that on the inflow side and the output side. We don't have anything doing external conditions. This kind of gets to what Jochen was asking for, to have some sort of sensing in the sorbent as well, so we can see how it progresses across. But I mean, we can do some interesting things with that, right? If we've got 6 units and they're doing runs fairly regularly, that's a good bit of data. And so, we can start to look at both positive and negative outliers, and there should be enough to start looking at some trends. If we can always collect a little bit of data with the system off to get a better sense of ambient conditions. So, there are ways to do that.
Okay.
I think we can get some very interesting data out of.
All right. That'll be very exciting. And I have one last thing to say, unless anybody else does, just about the future of the builds. As I've mentioned on this before, so we're upgrading UPenn, and hopefully that will be a permanent site of activity, whether it's improving the current one or having to really wholesale replace certain parts based on what we find, if we want to go with a cube chamber or whatever. But I feel good about that being remaining a node. UT Austin, really shooting for, which would be fantastic. IIT Bombay, so they're reviewing an MOU right now. The thing that would be amazing about that is that this is the team that's also working on that very low energy room temperature catalyst that mineralizes CO2 in water. So here we could have a bottom floor potentially if they want to experiment with that, where the CO2 flows into that tank and we mineralize it, which would be amazing. And then New York, a couple of options as we've always had. And I know, Jochen, you were even thinking at some point of, maybe talking to, some folks in your neck of the woods in Spain, but would be fun if we get at least a few builds this summer. And then after that, it's about sort of, exponential growth of the community, if we can work that out. Cool. Sandelia, where are you going again? I've asked you this like 7 times and then routinely forget it every time you tell me, but I can't remember what physically you're going to be.
After graduation, or
like Kentucky or something? Was that right? Or
Tennessee.
Tennessee.
I'll be joining Holocene. So yeah.
Okay. Fantastic. All right. All right, that's all I got. Unless anybody else wants to geek out on anything, I want to thank the 33 folks who tuned in or watching us right now. That's great. We just don't really advertise this; we just pop it up, so it means people are coming in, and we'll get more structured in our promotion of this as we get through some of these challenges, and then hopefully we'll not see 33, which is great, but we'll see 300 maybe as we get towards the end of the year. So, all right. I'm going to look into I'll ask Chuck, David, about those dampers if he thinks that those might be helpful. And then we'll be in the lab virtually next week, which will be exciting. All right, thanks guys for making it. Really appreciate it. Thanks everybody for joining.
Thank you.
Bye.
Likewise. Take care. Have a good week.
We got. Oh, sorry, we have someone from Octavia who's joining. I got to reach out. Thanks, Ian, for joining. I was watching. All right. Bye, guys.
Bye.